This week we're continuing with our trig ratios, and we are going to just start by reviewing the trig formulas that we've already learned. So the sine function, we find that using the formula sine equals opposite over hypotenuse. Cosine function, we find that using cosine equals adjacent over hypotenuse. Tangent function is tangent equals opposite over adjacent. The cosecant function, cosecant equals hypotenuse over opposite. Secant equals hypotenuse over adjacent. And last we have cotangent equals adjacent over opposite. So these are the 6 trig functions that we've already learned about. What we're going to be doing this week is taking these ratios and we're going to have to solve for a different ratio. So you kind of have to work around using the information you're given. So the steps for doing this, we will have, first we're going to draw a picture of the triangle and we're going to label the given information from the problem. Next thing, we're going to use Pythagorean theorem to solve for the missing side of the triangle. If you don't remember, Pythagorean theorem is if you have a right triangle here with sides A, B, and hypotenuse C, we have that A squared plus B squared equals C squared. So that's what we're going to be using for step 2. The last thing you do is you calculate the trig ratio. So in our example below, we are given that secant of angle A equals square root 13 over 2, and that angle A is in quadrant 1. We want to find the exact value of tangent of A in the simplest radical form using a rational denominator. So step 1 is drawing our picture of our triangle and labeling our information. If you notice, they mention quadrant 1. That means that we are on a coordinate plane. Our quadrants are 1, 2, 3, and 4. We are only using quadrant 1 this week, so your triangles will all be in this upper right quadrant. So we're going to draw a right triangle right there. If we think about secant, we just talked about the secant function. Secant equals hypotenuse over adjacent. Our problem told us that our secant of angle A, in this case, equals square root of 13 over 2. So the hypotenuse is square root 13. Hypotenuse is always right across from our right angle, so this hypotenuse here is square root 13. The other piece of information we have is that the adjacent side to angle A is 2. So this is our angle A. This is our adjacent side because this side over here is directly across from it. That's the opposite, so this is the adjacent. So we have 2 sides of our triangle here. Step 2 is that we need to use the Pythagorean theorem to actually solve for the missing side of that triangle. So this was our step 1. Step 2, we're going to use a squared plus b squared equals c squared. We have one of the legs of our triangle is 2, so we have 2 squared plus, we don't know this side, so that's going to be b. b squared equals, and c is always the hypotenuse, so we have square root of 13 squared. So we start simplifying. 2 squared is 4 plus b squared equals square root of 13 squared is just 13. Subtract 4 from each side. We get b squared equals 9. Take the square root of each side and we get b equals 3. In the first quadrant, all the sides of your triangle are going to be positive values, so that's why it's a positive 3 and not a negative 3. So we have b equals 3. Gonna fill that in. We now have all 3 sides of our triangle. The reason we needed all 3 sides is because when we go to step 3, calculating the trig ratio, we are asked to find the tangent of A. If we recall, tangent equals opposite over adjacent. The opposite side is right there, 3. We didn't have that information before, which is why we had to solve for it in order to get the tangent of A. So tangent A equals opposite, which is 3, over the adjacent, which is 2. And we can't simplify that fraction anymore, so this is our answer for that problem. Let's do one more problem like this. So our next problem, we are given that the cotangent of A equals 5/6 and angle A is in quadrant 1. Let's start with our picture. Got our right triangle. This is angle A right there. So we know that the cotangent equals adjacent over opposite. And in this case, they told us it equals 5/6. So our adjacent side to angle A is down here, that's 5. Our opposite side to angle A is over here, that's 6. We need to figure out what this is. That's the hypotenuse of this triangle. So we're gonna let that be C. So let's use the Pythagorean theorem. A squared plus B squared equals C squared. We have the legs of our triangle, so we're gonna have 5 squared plus 6 squared equals C squared. We wanna solve for C. 25 plus 36 equals C squared. And then this will get us to 61 equals C squared. We can square root each side. So square root 61 equals C. And sometimes you will get a radical for one of the sides of your triangle. That's fine. So I'm going to fill that in on my picture. So I now have all 3 sides of my triangle. My third step is calculating the trig ratio. So step 3, I want to find cosine of A. So cosine of angle A. We learned that the cosine function is adjacent over hypotenuse. My adjacent side to angle A is 5. My hypotenuse, I just calculated, is square root 61. I can't leave my answer like this though because I have a square root in the denominator. Whenever you end up with a square root in the denominator, remember we call that rationalizing the denominator is what we have to do. So we're going to multiply by root 61 over root 61. So this step right here is rationalize the denominator. And we've already talked about that earlier this year. So when I multiply across in my numerator, I get 5 square root 61. In my denominator, root 61 times root 61 is just 61. I can't reduce this fraction because 5/61 doesn't reduce, so this is how I leave my answer. So it's really important that if you have a square root in your denominator, you rationalize it, otherwise it will not accept that as a right answer on Delta Math.